All right, today we're talking about what I like to call the Swiss Army knife of AI. It's this incredible algorithm that you probably use every single day, and you don't even know it.
So let me ask you something. What do spam filters, face detection, and those fraudulers from your bank, what do they all have in common? I know, they sound totally different, right? But believe it or not, there's a single, powerful idea linking every single one of them.
And that answer is the support vector machine. You'll usually hear it called the SVM. Now look, it might not be the newest, flashiest AI model out there, but oh man, it is a true workhorse. Think of it as a master of classification. Its whole job is to draw this incredibly precise line in the sand between this thing and that thing.
So here's our game plan. First, we're going to meet this unseen workhorse. Then we'll see how it organizes our digital lives, how it powers the physical world around us, and even how it's helping us decode the very code of life itself. And we'll wrap up with the big takeaway, why this algorithm is still so important today.
All right, let's get properly introduced. The SVM is, well, it's a foundational algorithm in machine learning. You can really think of it as a master separator. It's just incredibly good at finding the absolute best, most optimal boundary between different groups of data. And that skill makes it super powerful and, maybe more importantly, exceptionally reliable.
Okay, first stop on our tour, the digital world. I mean, it's just a place of overwhelming information, right? Emails, search results, messages. It's chaos. We desperately need tools to bring some order to all that noise. And this, my friends, is exactly where the SVM really shines.
Just think about it. We are absolutely bombarded with text every single day. Emails, news articles, social media, product reviews, it's a constant flood. And for decades, the SVM has been one of the go-to tools for making any sense of it all.
And its range is just wild. That spam filter that keeps your inbox clean? Yep, there's a good chance an SVM is working behind the scenes. Figuring out if a movie review is glowing or terrible? That's called sentiment analysis, and it's a classic SVM job. It can even figure out who wrote a document just by their writing style, or what language it's in. It's a total linguistic powerhouse.
But it's not just about sorting the text we already have. SVMs are also absolutely crucial for helping us find the needle in the haystack. You know, in this giant ocean we call the internet, finding what's relevant, that's everything.
There are even these specialized versions, like one called SVM Rank, that help search engines learn how to rank results, pushing the best stuff right to the top. And they're amazing in what we call cold start situations. So imagine a brand new product gets added to an online store. There's not much data on it yet, right? Well, an SVM can still make a really smart classification with very little to go on, helping you find it.
Okay, now this is a really clever twist on the whole idea. It's called a one-class SVM. And instead of separating two different things, like spam and not spam, this one learns a baseline of what's normal. It basically draws a tight circle around all the normal activity, so if anything happens outside that circle, bam! It's instantly flagged as something weird, an anomaly.
And I bet you can already guess where this is just incredibly useful. Ever get that text from your bank about a weird purchase you didn't make? That's anomaly detection. It's the perfect job for a one-class SVM. It's also used to spot hackers trying to get into a computer network. By just knowing what's normal, it becomes this amazing digital watchdog.
So we've seen it in the digital world. Now let's jump into the physical world. Because the SVM's superpower of classification isn't just for text and data, it's for helping machines actually see and interact with the world around them.
Okay, so before deep learning kind of took over computer vision, the absolute gold standard for detecting objects was a combo of a technique called HOG and, you guessed it, an SVM. Think about the early face detection in digital cameras. That was it. And while, yeah, there are newer methods today, this classic approach is so darn efficient that it's still super relevant for smaller, low-powered gadgets like smart doorbells or little drones.
And its seeing abilities go way beyond that. In medicine, SVMs help doctors classify tumors in MRI scans. In environmental science, they look at satellite images to tell the difference between a forest, a lake, and a city. And on a factory floor, they're the brains behind systems that can spot a tiny defect on a product whizzing by on a conveyor belt.
And that factory floor example brings us to the whole industrial world. I mean, in places where efficiency, safety, and knowing what's going to happen next are everything, the SVM is this quiet but absolutely critical engine.
The real magic here is how it takes a bunch of sensor data and turns it into something you can actually use. So an SVM can listen to a machine's vibrations and predict a breakdown before it even happens. It can figure out exactly how fast a drill bit is going to wear out. And for a robot, it can look at sensor data and tell if it's driving on grass or pavement, or even feel if its gripper is about to drop something.
All right, for our final stop, we're going to zoom all the way in. We're moving from the huge world of factories to the microscopic world of our own biology. Because in the incredibly complex field of bioinformatics, the SVM is an absolutely essential tool for making new discoveries.
I mean, the amount of data we have in genetics and biology is just astronomical. Trying to find the important patterns in all that, the signal and the noise, is a massive, massive challenge. But this is where the SVM's strength with what's called high-dimensional data comes in. That's just data with tons and tons of variables, and it makes the SVM a perfect fit for the job.
And the applications here are just profound. We're talking about scientists using SVMs to look at gene activity, to predict different types of cancer. They can predict how well a new drug might work, which can speed up the whole discovery process. They're even using them to pinpoint really important locations right inside a strand of DNA. It's incredible.
So, okay, we've seen this thing sort our spam, detect faces, stop fraud, and even analyze our DNA. You gotta ask, right? In this crazy fast-moving world of AI, why is this classic algorithm still around? Why does it endure?
Well, it really boils down to three key things. First, it's just unbelievably versatile. We've seen it work with text, images, sensors, biology, you name it. Second, it's robust, which means it gives you strong, reliable results, especially with that complex data we talked about. And it's less likely to overfit, which is basically when a model gets too good at the data it was trained on and then fails on new stuff. And finally, it's foundational. It's a powerful baseline that every data scientist knows and respects. It's a solid building block you can always count on.
Which really leaves us with this final thought. In a world that's always chasing the next big thing in AI, what timeless tools are we always going to rely on? The support vector machine is a perfect example. It proves that sometimes it's not about being the newest or the most complicated. It's about being the elegant, reliable, and versatile tool, the Swiss Army knife that just gets the job done, time and time again.